The objective for 1.5 is I can use negative exponents and zero exponents. I can use negative and zero exponents. So the first rule we're going to write down is anything to the 0 power is 1. And we'll talk about why this works and how this works more in class. So x to the 0 power is going to be 1. Z to the 0 power is 1. Negative 4,732 to the 0 power is 1. 8 to the 0 power is also 1. Anything to the 0 power is always going to be 1. Then let's talk about the rules for negative exponents. So positive exponents mean repeated multiplication. We're going to write that down. Positive exponents mean repeated multiplication. Negative exponents mean the opposite. So negative exponents mean repeated division. Negative exponents mean repeated division. So first we're just going to do some examples that are we're going to rewrite them using a positive exponent. So 5 to the negative third power, remember it means repeated division, so it means you're going to divide by 5 3 times. So that's really the same as 1 over 5 to the third, because we're dividing by 5 3 times, so it's on the bottom of the fraction. Or we could say a to the negative fifth as another example, means we're dividing by a 5 times, so it's 1 over a to the fifth. The next kinds of examples we're going to look at are going to be to rewrite using a negative exponent. Rewrite using a negative exponent. So if we have a problem like 1 over 8 to the third, that means we're dividing by 8 3 times, so that's the same thing as 8 to the negative third power. Or if I have 1 over x to the fourth, that means I'm dividing by x 4 times, so that would be the same as x to the negative fourth power. Okay, the way I remember rules for using negative exponents is a trick, or just a way to remember, called the happy fence. So we're going to write that down. So the happy fence will help you remember this. And the happy fence means any exponent that's negative is going to jump over the happy fence and become positive. This line, this fraction line, that's going to be our happy fence. So I'm going to write that down. And then we'll look at some examples to see how this works. So for example 3, we're going to do w to the negative fourth over w to the negative sixth. So anything that's negative or unhappy is going to jump the fence and move and become positive. So w to the negative fourth is unhappy up here, it's negative, it's going to jump the happy fence, it's going to go to the bottom and become positive. So now it's a positive w to the fourth. Same with this w to the negative sixth. It's negative, it's unhappy where it is, it's going to jump the fence and become positive. Now I can use my old division rules, and I know when I divide powers I subtract, so it's going to be w to the second because 6 minus 4 is 2. For example 4, let's do y to the negative fifth times y to the 8th. There's actually two ways you can do this problem. I'm going to do it using the happy fence, and then I'll do it another way after. So y to the negative 5th is negative. It's unhappy where it is, so it's going to jump the fence and move to the bottom and become positive. This one is already happy. It's already positive. It's going to stay where it is. Now I can use my old division rules. 8 minus 5 is 3, so this will be y to the 3rd. I'm going to do this same problem another way now. We had y to the negative 5th times y to the 8th. This is just doing the same problem a different way. My old rule was, when I multiply powers, I add the exponents. Negative 5 plus 8 is 3, so it's going to be y to the 3rd. So you could do this kind of a problem either way. Erase that line. Okay, let's do two more. Let's do, for example, 5, a to the 6th over a to the negative 3rd. A to the positive 6th is already positive. It's already happy where it is, so it's going to stay on top. A to the negative 3rd is not happy, so it's going to move to the top and become positive. So I don't even need this fraction line anymore because I don't have anything on the bottom. I could put it over 1, but I don't need it. And then now I can use my old multiplication rules, and when I multiply powers, I add exponents, so it's going to be a to the 9th. So we could also use our old division rules. Our old division rules said when I divide powers, I subtract. 6 minus negative 3 is a positive 9, so I would still get a to the 9th power. We're going to do one more example. Example 6 is going to be p to the negative 2nd times p to the 4th divided by p to the negative 12th. So p to the negative 2nd is unhappy. It's going to move to the bottom and become positive. P to the 4th is already happy where it is. It's going to stay there. P to the negative 12th is unhappy, so it's going to move to the top and become positive. Now I'm going to use my old multiplication and division rules. 4 plus 12 is 16, so I have p to the 16th divided by p to the 2nd. When I divide powers, I subtract, so it's going to be p to the 14th power.